document development.
Well, only on like a B day.
No,
Yeah, with pretty much all
no, because it would be, biomed would switch
Wait,
to
so
our
Bree's
study
coming
hall
in this
time.
class?
Yeah, biomed switching.
Oh my gosh. She was in here already.
Oh, yeah, you don't have that.
Cause like our biomed would switch, our study hall would be banned. When you got to study hall, so you have study hall to use.
Well, I asked you about
Are you smarter than a doorstop?
Yeah, I watched it.
I'll go grab one.
Nice, glad wrestle. Somewhat distracted. But it was hard to bring them. Let's try to get clean like it's
What, you have to school?
Can we know away all of this personal finance stuff? I have so much crap that I don't want to use.
Sure you do.
No, I have none. I hate keeping stuff I don't want to use.
Like mine.
Are you just
I hate when it hangs out.
Yeah, but I literally know that I'm not doing it.
I like it.
because
I put in my college though.
Then he was like, you know,
You're gonna go for any health thing.
I would only have to take.
I feel like
You're gonna have to take it.
I'd be like, go
I've
finish
only
my
done it
eyes.
once, and I was
So
like,
then you take,
not bad.
I've done it like 3 times already with these ones.
remember.
Like last night, I was like,
Or
going to like
take
itch my
college
face,
anatomy,
like I
or
stabbed
take
myself on accident. I like pick up my face.
But it's captive.
I don't,
I'd rather
I want to feel like
You can't take them off, right? I feel like they have to be careful. And you realize you something like, they grow on your nail. You can't just pop them off.
I'm in speech right now, but
I know if that other is.
Like right here. On the bottom right there, mine are already
If I
so
could
round.
do it. When I get, just when I get this sweat, even if I get them really short, I'll just keep doing it.
But mine aren't like,
I haven't started to go out early. I'm really tired. I really just want to take a nap.
but mine, they only like,
Oh,
It's like gel.
for yours, they
And it ruins your nails. Mine is still ruined. I get mine done like before Thanksgiving.
2,000 hours.
when do you apply for your meeting? Yeah, so that's like,
You save these? What? I don't know anything. When I used to work at Pete's, Brenda works at Denver Trash Digger, but we didn't use it.
we get the 18 stuff.
15, this is a long weekend. We have this day off and this day off. I don't know why we have this day off. Oh yeah, that's next week.
wait, that means I want to drop Lynn Homestead.
Yeah, this week sucks. I hate school.
Oh my god.
When I graduate in 4 months or something like that.
Like, I'm gonna go sharing it, I'm gonna have those two. I'm gonna kiss and
half of those are ones I got.
I have to take college and either college engineering 1 and 2, psychology, advanced psychology.
Then you said if you want, you wouldn't have to take 2 years.
Well, I'll be there for 3 years.
Benton is not here.
Yeah,
We
I'm
got
not.
13 kids and 11 is supposed to be here, and it's you two.
What? Is Casey supposed to be here?
Yep, I got Casey.
Ah.
I
We
don't.
don't want
We're
to.
just gonna stay here.
We don't, yeah.
You should run down to the office
And
and
ask.
check.
Oh,
And I
man.
don't care if you're gonna be here. If they wanna add you into here, that's just fine with me.
Okay, I'll tell
We're
him.
gonna have to leave.
But
I guess the same. We're gonna say.
it's probably just a bookkeeping thing, and
Well,
they remember to have you.
our speech classes are done, but we'd like to just stay in here, down at the study hall. If they
I'm
want.
fine with that.
Should I go with you?
Yeah, I don't know how they're gonna.
Because what else is there for us?
Yeah.
Yeah,
We don't want to
like,
I
do
don't know, that's why I need to
anything else. But they're gonna
Because
be
like, what else can you take?
Nothing. It's pretty
I
hard.
don't know.
Maybe they'll make you take physics.
We already took it last year.
And then the first file might be.
Alright,
We
physics
should go
lab.
talk to Nicole.
Let's get going.
Oh, I hope you are.
Oh, yeah. In physics, we'll not do formulas anymore. Yeah. Right after we stop the breathing and stuff. No more blinking, no more breathing, no more swallowing, and then we'll put formulas after that. I need this one, that one, and it needs to work. And it does.
I didn't look at farm.
And then it's the copy it. Put it there.
I didn't.
Another one.
Chicken sandwich, corn. Chicken sandwich, corn.
No, you can take it as like an actual.
Thank you.
I told you it wasn't in my pickup.
Yeah, I thought it was.
Where was it?
In my car,
But like where?
like, under the seat.
I told you.
Because when Gene office was this week.
Oh my god.
Good. Because you have like holes all over the front. Too. Cartoon chicken.
Alright, people, your first official assignment
Why?
for the second semester is to watch this cartoon.
Wait, pause.
That's it? Watch
Did
it?
Manuel like actually go back?
No,
Where's
he
that?
is in Hot Springs.
Why?
That's where they found his family.
Hot springs, like we're by Costco.
That sucks. Okay, continue.
Are we ready now?
Yeah.
Yeah.
Okay. We need the lights out?
Yeah.
You can fall asleep? This is actually a part of your assignment, so don't ignore it.
Like,
Gravitatus maximus.
We got there.
But
not-
we're
not-
in here today.
yeah.
I'm sorry.
No, it's alright. It was gonna happen. She was.
They don't make them like that anymore. So, that's the first part of your assignment. Here's the second. 14 minutes of your life, right? Guess what your assignment is? I am going to modify the instructions that came with this unit that are attached to the Edmodo assignment, and we're gonna do a warm-up. And your warm-up is this. Open up a Word document. And I want you to document how far Wile E. Coyote fell. Just do the first video. Zoom and forward.
How far do you go?
How far did Wile E. Coyote fall? Every time he fell. The video's right there. It's a link, it's in Vimeo, it should work.
You just guess.
How far are the quality?
Yeah, that's how you're supposed to like know.
It's physics class.
Yeah.
How are you supposed to know? Anybody? Yeah.
Never did.
Okay, I'm over there, I'm watching you watch this. And I'm thinking, when my kids were little, they had those stupid dinosaur movies.
Land Before Time.
I don't even remember.
Pretty good.
One of the little dinosaurs was Petrie. And he kept saying, I fly, and they'd say, nope, you fall. So how far did Wile E. Coyote fall? At what point in the video was it that he fell? And how do you know that's how far he fell? You should be able to answer all three of those questions about every time he fell. Let's see if it loads for other people.
Yeah, it's not really.
It's not loading? So maybe we have to do that part together.
Why wouldn't you just slow motion it, count the things?
Maybe, maybe not. How far did it fall?
Slow motion it, count the things, and then figure it out.
Frames per second, and then we can figure out how many seconds he fell?
Yeah, and then you can figure out how many,
How do we do
how
that?
far it fell. Because if you have your frames per second, and then you count how many frames, then that's, so, what? Frames per second, like if you go full motion.
These two things have way different mass?
Yeah.
Are they gonna
So
fall the
one
same?
will fall faster and one will fall slower.
They will, okay. So if I put them right here, and I use this to push them off, they'll land at a different time. Question mark. No?
We tried that out like
Yes.
last semester, I think.
Everybody give me an answer, yes or no? Raise your hand if you think they're gonna land at a different time.
You're not gonna be able to
What are
tell
they?
because like,
Oh, yeah.
They're gonna land at a different time? What about the middle row here? Different? How many,
That was different,
how many clangs did you hear?
like 4.
But, was that these things hitting at 4 different times, or did
drop
they hit
them
and
at
bounce 4 times?
drop them at the exact same time, like straight down. From the exact same point. Alright,
So from the same place?
yep.
And they'll land at a different time? There won't be one click when they both hit the floor at the same time?
That one hit first. If you watch the floor, you can see it.
So we need everybody to lay down,
No, just look at it. You just have to look at the floor.
and they're landing at the same time or different time?
I don't know, but we're good.
Do it again.
different.
Do it again.
There's errors that can. Gravity is the same, but
Somebody was really busy. There we go.
That looks like something I would do.
I've got one of these. I've got this. Now we got a way different mass, right?
Yep.
Not even close to the same. So if I push them up here, we should be able to find a pretty good sized difference.
If you push them at the same time.
That's what it is.
That looked pretty much the same, didn't it?
Yeah.
Okay. Now if we go back to this, can I do this and have it be fair? Because the bottom of this one's already 2 inches closer to the floor. But if I put them right here,
That'd be right.
and I try to not hit the chair. About the same? It looked like this one was ahead for a little bit.
Yeah.
Did it slow down? Or did it stick to my thumb, and when I pulled my thumb off, did it have a
Gravity.
little extra speed? Because it stuck to my thumb.
Gravity pulls everything the same, but then your air resistance.
That's pretty much the same, right?
I'm confused. I'm confusing.
Do we need to find things that are more different in mass? Or can we say they're the same? How about if you go to the web and try and confirm? Do all things fall at the same speed? If I was in my room, I spent the last dozen years in, I'd have a bowling ball and a stress ball. And a ping pong ball.
Yeah,
And a fire stick.
they do.
All things fall at the same speed?
Yeah.
So it doesn't matter if I got a shot put or a marble?
Ignoring wind resistance, all objects fall at the same speed while under the influence of the same gravitational forces.
Okay, so
unless
if we're
you have,
near the
like,
surface of
wind-
the earth,
If there's like wind, then it won't fall at the same, like it depends on like.
so you're telling me that paper and rocks don't fall at the same speed?
No,
Because,
because paper's flat and so it floats and goes like this because of
and
the
the
wind.
air screws it up. But what if we put paper in a vacuum, so there's no air?
Then it'll go at the same speed.
So you've seen the feather and the bowling ball experiment?
I think I did like.
Look on the web, find feather and ball
1,000 pounds.
vacuum.
Oh, never mind.
I'm sure you can find it. Oops. I can't forget to go to the first.
Okay, so like no aerodynamic objects will fall faster than objects that don't allow air to pass by them easily. Try this with a sheet of paper and a marble. Bottom line, all objects do not fall at the same speed. But yes, all objects fall at the same speed because the speed of gravity on Earth, which is whatever that is. So they do technically, but they don't.
So it depends on the situation, right?
Well, it depends if like something is like aerodynamic or not. So like if you have a marble and a bowling ball with no holes in it, and you drop them at the same time, they're gonna hit the ground at the same time. I love Pringles.
This is NASA's Space Power Facility in Cleveland, Ohio, and it is the world's biggest vacuum chamber. It's used to test spacecraft to the conditions of outer space, and it does that by pumping out 30 tons of air into this chamber until there are about 2 grams left. And it's got an eccentric construction.
Okay, time out. How much air is in that chamber? Really? Is that chamber bigger than your gym?
Probably.
Taller, right? So your gym has 10 tons of air in it? Is that possible?
Sure.
Can you run through 10 tons of air?
Yeah.
Doesn't it hold you back?
Yeah.
Why don't we think about that every time we walk or move?
You don't feel it.
Because
We're used to it.
you're used to it.
You're born with.
There's a commercial for Breeze that talks about, you think your bathroom smells okay, but other people see this and then it changes into an outhouse, stuck into a hole in the wall. Because you're used to it. So there's air pushing down on you 24/7. There's air holding you back and fighting every movement you make 24/7. You move your arm. There's air fighting you, but you don't think about it because it's there all the time. In physics, we have to start thinking about things like that.
Which is part of this history. It was built in the 1960s as a nuclear test facility to test nuclear propulsion systems. And that meant that they built it out of aluminium to make the radiation easier to deal with. Aluminium is not the best thing, it's the strongest material to build a vacuum chamber out of. So they built an outer concrete skin, which is part radiation shielding and part an external pressure vessel, so that this thing can take the force that's present on the outside when it's pumped out to the conditions of outer space. Galileo's experiment was simple. He took a heavy object and a light one and dropped them at the same time to see which fell fastest.
We should have known that was going to happen because,
I mean,
how did you know they're there?
he took a heavy object, and a light one, and dropped them at the same time to see which fell fastest.
Because he's still in the room.
Yeah.
So you know the feathers are going to fall slower. That's what would happen in this room, question mark?
Yeah.
Now in this case, the feathers fell to the ground at a slower rate than the bowling ball because of air resistance. So in order to see the true nature of gravity, we have to remove the air.
Which way does that door curve, in or out?
It takes 3 hours to pump out the 800,000 cubic feet of air.
Worker, out.
We dropped 2 millitorr in the last 30 minutes. But once it's complete, there's a near perfect vacuum inside.
6104 manual, 10% open. Station 1, go for drop. PCB 30-1, pressure set point at 240 psi. We are go for drop. 10, 9, 8, 7, 6, 5, 4. Cameras on, 2, 1, release.
You see the hairs on the feather moving?
Look at that.
They came down exactly the same. Wow.
Exactly the same. Exactly the same.
Feathers don't move, nothing. That's just brilliant.
Isaac Newton would say that the ball and the feather fall because there's a force pulling them down, gravity. But Einstein imagined the scene very differently. The happiest thought of his life was this: the reason the bowling ball and feather fall together is because they're not falling. They're standing still. There is no force acting on them at all. He reasoned that if you couldn't see the background, there'd be no way of knowing that the ball and the feathers were being accelerated towards the earth. So he concluded they weren't.
Things that make you say, Everything near the earth falls at the same rate. What is that rate?
9.8.
9.8 what?
Meters per second.
Meters per second what?
Squared.
Squared. Because it's, why is it squared?
I don't know which is.
You told me when you do stuff with something else.
Why is it squared?
Because
Because your time's in the garage.
What is this?
Times 7.
This is a speed, very good. This is speed because it has a distance divided by a time. Same as that one, right? Which we don't write that way. We write it that way. And you see that every day. Speed. What is that?
Time.
it's a speed. It's a pole.
Forward.
Meters.
The speed
It's a
divided by
velocity.
a time, almost a velocity.
I give up. I'm done.
This one's a velocity or a speed. I don't care which one you use.
Acceleration.
It's an acceleration because it's a speed divided by, again, time. Which is going to give you a change in velocity per time. And if velocity is changing, that's what we call that A word that Brittany used.
Acceleration.
That's what we call an acceleration. An acceleration describes how a speed changes over time. What do we call the gas pedal when you use the correct terminology in a car? It's an accelerator. Because it makes you accelerate. What's accelerate?
Go somewhere.
Faster.
Use fifth grade words.
Picking up speed.
Go faster. Pick up speed. It changes your speed and it makes it greater. The pedal on the left
Slows it down. Increase.
should be called not a brake but a decelerator because it changes your speed, slowing it down. But those big words have a simple meaning, don't they? Okay? So, back to your assignment. Before the class is over, in the next 40 minutes or so, I need you to tell me every time Wile E. Coyote fell, and how far he fell, and how you know that.
You don't know how far. You don't know how tall enough.
Oh my goodness, lad.
So I have the right one, yes. So I'm gonna get rid of the other one.
But you have to play it in slow motion, so how you gonna do that?
No, I don't. Another way. What way? So, what do you got? title it about anything you want. Cartoon Physics 1 would probably work. It's actually the warm-up. I need to know how far he fell. I need to know where in the video that happened. And I need to know how you know that's how far he fell. I need you to prove it beyond the shadow of a doubt. Probably mathematically and scientifically.
All in 40 minutes.
Yep.
This doesn't make sense to me.
It will in a second. What happens next?
Well,
How far did he fall?
Hold on, 1:15.
That's right.
Just give me
Stop
a
and think,
second.
Don't just sit there and spin your wheels and grind on the fact that I don't know. What can I do to figure it out? That's what you need to be asking yourself.
Hold on, I'm typing. Okay. So if you write down the time that it starts and then the time that it finishes, then you can probably figure out how many frames per second, and then,
Or every single one of you owns a stopwatch.
do some of this room.
you know what?
Alright.
You have a stopwatch on your phone, right?
Yep.
And we can have 11 people do a test, and then we can compare all of their number.
This is in longer than 40 minutes.
I'll bet it does.
I don't even know what we're doing. Go.
Keep
Are you
going.
ready?
And you can stop watching.
We need time.
Hey, go, stop it right now.
I don't know when he's gonna fall, so
Really?
back this up a couple seconds. Everybody got your
You
phone
can
ready?
Just do that.
Yes.
When he starts to fall, you hit start. When he lands, you hit stop. I don't know if we get to watch him land, but we always get to hear it, right?
Okay, go.
So you're gonna wanna be quiet.
Go.
I got 4:45.
All right, everybody go write a number on the board. Put them all in a nice, neat little column. We should probably not mess with Mr. D's stuff.
What if we
He
got
needs
the
it
same
enough.
number as someone, then they can just write it.
I haven't written since school ended, so I don't know what writing is.
Hey.
And then when we're done, we can average them, and that'll probably be right. Unless somebody got something that's really wacky.
I'm going up there.
Yeah, but we also all have different reaction times.
Yes, we do.
Just pointing that out there.
That's a good thing. I like that.
Man,
That's 8, that's not 11.
Mine's the same as Debbie's,
Go up there and write it.
are you serious?
I don't have the time.
No. I just say things for no reason.
Okay, so you average it, you add them all together and then divide by the number you have, right?
I don't have the time, because I have to download.
Because you, okay. So we got 10 of them? 2, 4, 6, 8, 9.
Now what?
That means there's 2 of you didn't do it? Nope, there's 10 in class, not 11. Average those numbers. But, everybody has a different reaction time. What would we do with the number that said 3.7?
Wouldn't have it.
What would we do with a number that said 5.6?
Would
If one of you had that on your phone,
divided by, wait, 1.
there's 9 of them up there.
That doesn't make any sense.
What the?
What'd you get, Brittany?
36.47.
Nope, that doesn't make any sense.
Oh my God.
Let me do it on like an actual calculator.
If you add them all up and divide by how many there are.
Okay, hold on.
I would open the spreadsheet and type them all in there and written a formula that says equal sum and highlight all of them and hit enter and it would have given me the total.
I got 4.48.
27.
Why do you choose 4.41?
Did we get that in multiple places?
4.31. Give me a second.
Well, there's only two people trying to do this, that's my point.
4.41. Add it together. Oh wait, delete that equals divided by 9. I got 4 point. It's like 4.487. So would you round it up? Well, it's got a bunch of numbers. Do you round it up though?
What's after the 7?
Another 7.
Another 7?
So like,
That's what I got, but I did something.
You just chopped it? Instead of
why can't we
rounding it?
just say that it's 4.9 or 4.49? I mean, because like you would round it up.
I've got about 36 different science concepts going on in my head. Why do we have to have everybody put a number up there? Why can't we just have Brittany do it?
Because that's not the average.
When we do 9,
And like I might have a slow reaction time.
we can adjust for reaction time because somebody else might have fast reaction time. Somebody else might have anticipated it and actually hit it a little bit early to counteract yours. This is why we have multiple trials in science. We don't try something once and say, yep, that's how it works. We try it a whole bunch of times. Before we came up with the 9.8, that was tested literally thousands and thousands and thousands of times by way more than one person,
Okay, moving on. What do we do next?
okay? Everything in science is done over and over and over and over by hundreds of people before we decide, yep, that's what it is.
Okay, moving
So-
on.
Can we take this number and run with it?
Yeah, probably.
If we do it over again, are we gonna get the same number?
No,
The same fall,
no,
the same measurement? Should.
you shouldn't.
Let's try.
Are we serious?
That would be science.
Yeah.
We go back and try it again. So he's gonna fall in like 4 to 5 seconds. Is everybody ready?
Yeah.
Yeah.
Hold on, let me get my phone out.
That's exactly what I'm doing.
Yeah. let me find it. It's not no more, can we just wait? Oh, 30 seconds. You can go on.
You have to wait 30 seconds?
Yeah, I just locked myself out.
Uh-oh.
Go on.
Was patience on that list of 21st century skills?
Yeah.
I bet it was. Well, it should be.
Well, I'll bet you.
Ready?
Yeah, I'm ready.
Are we going?
Alright, it's gonna go in, I think 4 seconds.
Okay.
There's also a sound.
Oh, shoot.
Good job, Hannah.
I'm twisting my words.
Are we looking at about 4.49 seconds on your stopwatch?
That's horrible, man.
Oh,
I didn't stop
that
it
is so
already.
weird. Me and Nikki got the same thing that the other one got.
I think maybe we're gonna wanna write them down again.
Hey! No, guys.
I wanna do
Starting
math
guys
here.
too late. I'm right back.
Just give me your numbers.
Stopwatch only goes like
8:30, but I started.
Mine didn't work.
Like, I started my after.
You go to your,
I got
I went to
6.
this other institute.
That was horrible. I mean, button.
It's in your clock and,
Well, mine,
Yes.
mine was 688.
yeah, I'm not writing that down.
Yeah, yeah,
Ah,
yeah, yeah.
this is dumb. What's yours? Oh, 440. Is that ready?
No, mine didn't work. Yeah, mine didn't work either, cause I
All right.
pressed reset, so.
Time out.
I'm using my calculator, I don't trust my phone anymore.
Why do we cross that one out?
That's too
Mine
high.
messed up.
Cause
How do we
line,
know?
cause
He
the
said-
6
he said
seconds
he messed
is not
up.
true.
Well, when we look at everything else, we can tell, right? That just kind of sticks out like a sore thumb.
Yeah,
Like, oh,
right
man.
wrong. What you?
I'll bet somebody tried to hit the button and missed and had to hit it again,
Yep.
okay? So, you're gonna find things like this in science. You have to record them. And you have to document what happened.
Mixed by code.
How many do we have? 1, 2, 3.
This is transparency in science.
We have 7.
Otherwise, when we do this, hang on.
Did you get some time? I don't know if you get 4.325.
Now we have the same number of data for each one, right?
Well, we don't have all day.
If you don't have the same number as in your second trial as you do in your first trial, how do I know you're not cheating and fudging stuff and trying to make the numbers come out the way you want them to come out?
Hey, what's our next step? We only got 40 minutes.
I know.
We have
Chill.
like 30 now.
If I can figure out a way to capture carbon from exhaust stacks, and nobody cares because nobody wants to capture it, but I can figure a way to fudge the data to make it look like the global temperatures are going up, I'm gonna make millions of dollars if I can make people buy my stuff. That's important. On the other side of that, if the temperature really is going up, is that gonna make things better or worse?
Matter. It depends what the weather is,
It all depends, right? But it all depends on, at its very basic part, it depends on the data. And the data has to be reliable, and then we have to make sure that people analyze that data without bias. Okay? Global warming is one of the things that's in the news all the time. If we put this one in there, does this number match that number?
We're just gonna burn it.
How come we have two separate things here? 4.40, almost 9, and 4.32.
You get less than
Percentage-wise, that's significant, isn't it?
It's because, like you, I don't know, because your reaction time's probably shorter the second time you watch it because you've done it before.
Well, then we better do it a third time to make sure we
I
know which
hate
one of those is right.
everything. No, can we just do the average of like those two?
Yeah.
Here it comes.
I'm not ready.
I'm ready.
Ready.
We're about 2 seconds from lunch here. Tell me when to go.
No, no,
I'm spoon ball.
not ready.
Everybody there? We're about 2 seconds from lunch here.
Nope, I got it, guys.
Boy.
Faster from just one of us to write it.
4.33.
I got the same time that I got the first one.
Did you?
Exactly.
Maybe.
Go.
4.33.
4.36. 4.43.
Man, I'm a bad person.
What did you do?
I got 418.
4.37.
4 point what?
37.
Buddy, what'd you get?
418.
You shouldn't have ordered.
4.31. 4:45. What? 4:45. Okay. I thought you said 4.5. I got 4.30.
Yeah, which one? 40.
6.42.
Sensitivity.
My thing was being down. It's like when you started, it hit wow or something.
2, 4, 6.
Swear to God, if we
8,
roll this again, I'm walking out.
Tiffany, you ruined it.
Okay.
Because this is gonna be interesting to see if it's more like the first one or more like the second one. And we should have at least 4 people doing the math here. Actually, we should have 10 people doing the math, but.
What's the second one? Is that a 0?
That's a 0.
5, 6, 7, 8.
2, 4, 6, 8, 9.
Oh, what are we divided by?
9.
I did something wrong.
I 8 point. Wow. I did that wrong. Okay, 8.6.
Divided by 9.
I don't know, I messed up. I got
2.8.
13, so.
I got 9.
What did you divide it by?
9.
You add it all together, so then you get like 30 something
Yeah,
or
and then you
whatever the
divide by
number
9.
is, and then you divide it by 9.
So 3.8.
6. 6. Think you missed the number.
How did you do it?
I'm not doing it again.
Oh, shoot. I'm right next up.
I'll do it on my phone calculator. It's like down and doing it twice.
You're good.
Oh, no, okay. This is 0.
Oh, wow.
Demi, got an answer?
Nope.
I got that this time.
Yeah, no. I did it on button, so I did it.
Yeah.
Divided by 9.
Yeah, I got that.
I got the same thing.
Yeah, I must have not added anything.
So now do we have to do the average of those two numbers?
Unless we can figure out that one of these is way off for some reason. But no.
This one, wait, no, we're just gonna do the average. 'Cause they're-
I think these went down because you got better at the skill, at the timing things. But, let's take the green one and put up an average.
There's, equals divided by 3.
4.3863.
We got something.
So we could agree that he fell for 4.3863 seconds.
Precisely.
We should probably
No,
agree that
we're not doing it again.
we shouldn't have 4 decimals. That we're not that accurate, we're not that precise. So we should probably go to 4.3.
4.39.
Approximately equal to 4.39 seconds. And we're probably inventing some precision there as well.
So then, if you have your total average and it's 4.39 seconds, and you know that gravity would pull him down at, what is gravity?
9.8 meters per second squared.
9.8 meters per second squared. So how do you figure out, like, how do you get from that you know that he fell 4.39 seconds to like figuring out?
Sure.
Where are you getting your 4.39 from?
How far are we? Okay, so like the 4.39.
We did 3 trials.
Yeah.
Everybody in class measured it. We averaged each trial, and then the 3 trials got averaged together to make that number.
Okay.
And then we just rounded it up because we didn't need 4 decimals. So like how do you get from like that he fell
That becomes the next question.
the second, like how long he fell to like
If we know it took him
4.39 seconds?
4.39 seconds, and that's our only given information, how do we convert 4.39 seconds into how far? When we measure how far, what kind of label are we gonna have?
Meters per second. Or frames per second.
Distance should be measured in what? What kind of label should be on it? Meters per second?
The distance.
Are you sure?
I don't understand what you're asking.
Do we wanna discuss that?
What?
Distance should be measured in
Meters?
meters. So how are we gonna get seconds turned into meters?
Find like an average?
Fine.
How do I word it then? Average distance.
You wanna do it with logic first, or you wanna do it with math first?
Wait, wouldn't it, cause like you have gravity at meters per second, so then,
No, gravity's meters per second squared.
but there should be a formula that you can put that in 4.9.
Do you want a formula? Do you wanna just think about it and use logic and common sense?
Think about it.
Okay. So if we're gonna draw a picture of this, he starts here, and our time is 0. Our distance is 0, right? And then he falls. Are those approximately the same distance apart? I didn't
Yeah.
measure them. If I'm making a graph, I should probably measure it, but we don't have time for that. What does this say?
5.8 meters per second squared.
So at the end of 1 second, how fast is he going?
Squared. So that'd be like 30 seconds, right? No.
But what if I rewrite that 9.8 meters per second? Does that now say that his gravity accelerates objects 9.8 meters per second each second?
So then that means like at 1 it would be 9.8. Right? So then it's technically really
At
easy.
the end of 1 second, he's going 9.8 meters per second.
So then at 2 it's 19.6. Then it's 29.4. Then it's 39.2. It's 49.
49 even.
We'll look at the 0.2, because then you're adding 9.8 to the
Sure.
0.2, so then it would make it even. So then, like, if you take the 4.9, so then all you would have to
Look.
do.
You're right, but let's take a pause here. Does that make sense?
No.
Do you know where the numbers came from?
Yeah.
Okay, so like if you think about it,
9.8.
He's holding still.
okay, so you have like your 9.8, and so like if you look at the equation for gravity, it's 9.8 meters per second per second. So then like every second he's falling 9.8 meters.
Every second he speeds up 9.8 meters.
Yeah, so then you add it, so like 1 second it's 9.8 flat, and then 2, and then you just, that's where it's at.
So, nine point eight times 3, 9.8 times 4, 9.8 times 5. So if he fell for 27 seconds, you take 9.8 times 27, and somebody asks you how fast was he going when he hit the ground? Well, it's 9.8 times 27 meters per second. Simple? So, if I drop the paper clip and it falls for 1 second, how fast is it going when it hits the table? 9.8 meters per second. That's a rate, that's a speed, okay? So, what can we do with that?
Speed times time is distance.
If he started at 0 and he ended at 9.8, how far did he go?
1.
Did he go 9.8 meters?
No, 9.8 meters per second.
And that was his ending time. And he had to speed up to get there? So there's no way he went 9.8 meters. It's less than that. Is there a way that you can find the distance traveled given a starting
Distance
speed
equals,
and an ending speed?
distance equals 8.5.
Yes, it does. But your rate is changing, so you can't use it.
Pretty sure when you fall, you're gonna be stopped.
Yep.
Well, here you go, that's the answer, moving on.
Nope. You have to have something with a V1 and a V2.
Well, like the answer
Maybe
for
your
like at
acceleration
4
is-
point,
the acceleration
And it might not be V1 and V2, it might be a VI.
if you want the
And a
answer
VF.
for like the 4.09, it's 40.02. Or 43.02.
That was his ending speed
Yes.
at 4.39. 40.02?
43.02.
So you can add in an impact speed.
So do you say like on this, do you say 43.02 meters per second, or is it still squared?
No, it's meters per second, because that's the speed.
Okay. So then how do you find out?
You need a formula that's got these two and a distance. I'm not sure.
I thought you said your teacher made you memorize all of them.
How does that work when you're 50? And you had to memorize them when you're 17.
You should know that.
You know how memorizing works. Memorizing is temporary. If you don't use it over and over and over, it goes away.
Your physics teacher.
And I have no reason to memorize them anymore. They're all out there.
So why can't we find it?
semester test.
What are you looking for again?
Did I give you formulas for your semester test?
Yeah.
In the pictures?
It was in there.
Right there.
It was in there.
What are we finding?
You need to figure out the distance.
Okay, uniform acceleration.
Yeah.
So it'd be D equals 1/2. Are you ready? And then parentheses, VF plus VI, parentheses, times time.
Super horribly complicated, right?
Yes.
Distance equals 1/2. What's VF?
Something. Just give me a second, I will explain it.
Velocity. If I want to know how far did he go in the first second, how high do I have to lift this and let go of it? So it's going to take exactly 1 second to hit the ground. How far is that? The answer's right here, right? Because this is 0. This is going to be some number of meters. What happened to the speed? It started at 0,
Accelerated.
it finished at 9.8.
So like your VI is like
Acceleration.
where he's at, or what his speed
What's
is.
the I for?
VI is your speed.
What?
No,
Kissing.
You had speed then?
And VT is like the
Vocabulary.
VF.
end, or VF is the ending.
English class. An F word for ending.
Finish.
Finish or final. An I word for beginning or start.
Initiation.
Introduction.
Shorten it.
Introduction.
What's the root of
Intro.
initiation?
Intro.
Initial.
I don't know. We suck at English, come on.
This is your velocity final.
So then it would be D
This is your
equals,
velocity initial.
okay, then plug it in. D equals 1/2,
Why is
and
your
then
finish
VF would be 43.02.
Can I take 0 and subtract 9.8?
I hate my life.
Am I going to get positive numbers? Did this get faster or slower? So we have to start with the final so that we can subtract the initial. In this particular case, we don't want to subtract, but a lot of times we do. So it's almost always. If you want to know how much was the increase in speed between second 1 and second 2, you would have to take the final minus the initial. So in physics, the scientists pretty much always write the VF first, even if it doesn't have to be.
So then it'd be equal. So your VF is 43.02, right?
Yeah.
Plus. And then is VI is 0?
Well, this is initial velocity.
0. But then is the time like what? 4.2. Apparently that's not always fine.
You can get something around 88. Well, just doing the math with the whole numbers, I got to 84, so I figured it's probably going to be 86, 87, 88. That math. Half of 43 is 21 and a half. Times 4, 21 times 4 is going to be about 84.
21, 20. I got 94.4.
I have like
Yeah,
a
that's-
20,000.
Okay.
But I don't know.
And 442?
So like, wait,
Yeah,
when
well,
you
the
do.
2 rounds up to a 3 if you want to.
Okay.
Doesn't matter.
I do.
Okay,
So in the first fall, Wile E. Coyote fell 94.43 meters. He impacted the ground at 43.02 meters per second.
That's actually really easy.
Attention students and staff. Students, you will be allowed to eat in the LMC during lunchtime this semester, but the students are responsible for cleaning up any messes made during lunch. If the LMC is not kept clean, you will not be allowed to eat in the LMC anymore. You are still not allowed to eat anywhere else in this building, but you are now allowed to eat in the LMC. You clean up after lunchtime.
Enough people finally complained.
And you can convert both of those numbers to something that's in the American system so that we can understand it.
I understand meters just fine.
Yeah,
Meters are okay.
meters is like.
But you need to
Do you want yards or
communicate
feet?
to
Do
your
you
audience.
do you
I want you to
want
convert
yards or feet?
when you're done. Whichever one makes the most sense.
You know what? I'm just gonna look it up.
And show your work.
No.
I'll link the page.
Yeah, I'll copy and paste it.
No.
I'll take a screenshot.
You need to do dimensional analysis.
I hate to tell you this, but you kind of failed at teaching me that because I have no idea what to do.
I hate to tell you this, but you kind of failed at learning it. I
Well,
taught it well.
I don't know how to do it, so.
I know. That's because you never tried to figure out how to do it. You tried to figure out how to get around doing it.
No, I actually did try.
Which you did.
So
Well, yeah,
good
but
that I
not-
figured all of that out just now.
Yup.
309.8.
Yeah.
He said that Eric had done it.
But how do you like actually figure it out though?
And he was down there and asked him, so he was some insurance.
I have to open an Excel document.
So,
Right there.
he fell 4.4 seconds. He was going 43 meters per second. We should convert that to.
I'm so lost.
And he fell 310 feet.
Okay.
That's most of the final information after we convert to 4302.
Is
Yeah, exactly. I don't know.
so now what?
You got the 4302 converted?
I remember when I was there.
To what? What do you want?
It's probably really not that bad, but I just thought it was really I didn't even get close initially though. Hopefully I don't want to think counting and he said that it'd be hard for me to.
How many meters per second?
4302. Converted to miles per hour.
Why not feet per second?
So hopefully I don't think.
People don't understand it. People drive miles per hour every day.
I don't care about people. Rain.
He said like Josh.
Does this do
Now or next time?
We'll talk in a second, as soon as I get this number.
96 is one,
That they
2,
have
3.
down there, they help the teachers and stuff and
All right. So, what we were able to figure out during class today.
The impact, how long he fell each time.
He fell for 4.4 seconds,
Yeah.
which means that he fell 310 feet.
Yep.
310 feet is what compared to a football field?
About the same.
Yeah, football field is how many feet?
300.
300. So he fell a football field and how high a basket is. Because basketball hoop is 10 feet high. And when he landed, he was going 96 miles an hour.
He
All of
would've
that is true except,
totally been dead.
except,
He would have totally been dead.
well, of course he would. Which part of this can't possibly be true? No. Some of our math has to be wrong.
Oh, the, like, how they
Time.
found the time, because, like, reaction time is, like, a difference.
This number has to be wrong. Why?
That's what I just said.
Because a meter is way smaller than a mile.
The other video that I went out about, feather. Is Wile E. Coyote a bowling ball or a feather? He's in between. Right? If you jump off a 300-foot cliff with bowling ball and feather,
So
and
what's
you
the
take
point
the
of,
step and you let go of them, which one's gonna hit the ground first? The bowling ball's gonna hit the ground first. Who hits the ground last? The feather.
so what's the point if we're not finding an actual answer?
This is done, the math is done without accounting for air resistance.
Yeah, so let's not count for
Is it
everything.
gravity?
No air resistance. If you're in college, I make you figure out the coefficient of friction between a body and the air and free fall, and then do the math.